All right, here's an estimation problem. They're giving us this graph of the function I, which is equal to the integral from 0 to 4 of the function f. So that would be the area underneath that curve. They want us to use this graph to find the Riemann sum approximation of L2, R2, and M2, where L would be left endpoints, R would be right endpoints, M would be using midpoints. Let's start with the L left-hand one here. The 2 indicates they want us to use two rectangles. If our length here is 4, that means our change in x here is going to be 4 minus 0 over 2, which is every 2 spaces they want us to make a rectangle. So that would be right here. So using left endpoints where the left side is our height, that would be this rectangle for that one. And then the other rectangle would have the height on the left side here, so that rectangle. So if we add up these two rectangles, what is that going to be? So our L2 approximation here is going to be our change in x here, which would be 2 times the function values, so that'd be the function value at 0, plus our change in x times the function value at 2. And then we know that our change in x here ends up being 2. F at 0 is the height here, which is at 0.5. Again, our change in x is 2, and then our function value height at 2 here looks like it's 2.5. So if we add this up, half of 2 is 1, 2 times 2.5 is 5, and so it looks like our L2 value comes out to be 6. Let's find our R2 value. So now, same change in x, but for our R2 value, now we're using the right endpoint. So our first rectangle would use the height on this side. So we'd be looking at that rectangle, and again we're using the right side of this, so the height here. So what's the area of those two rectangles? Our change in x is still the same, it's going to be 2, but now our function heights, we're using 2 and we're using 4, and so we still have 2 here as this value. Our f of 2 from before is 2.5, and the height at 4, if we go across here, is right there. It looks like 3.5. So adding this together, now we got 5 plus 7, or 12. So that approximation comes out to be 12. Now the next one they want us to find, what would the midpoint approximation be? So for midpoints, we're using these two same rectangles if we want the height to be the middle of this, so that so we'd use the height there, which would be this rectangle, so that's the height because that's the middle of 2. For the other rectangle, we would use the height at 3, so if we follow that up, that's where it hits there. So our rectangle there would be this one. All right, so what is the area of those two rectangles? That would be our midpoint approximation. So midpoint approximation here of 2. Again, change in x hasn't changed at all. We're still using the same one of 2, but now we're using the height at 1 and the height at 3, because those are the midpoints of those two rectangles. So we'd end up with 2. We got to estimate here what our f of 1 is going to be. It's a little bit over 1.5, so maybe like 1.6 here we'll estimate that to be. Here it's 2 again. Our f of 3, it's a little bit over 3 there, maybe, I don't know, maybe like 3.2. we'll go. So what do we get here? Looks like if we double that, we get 3.2. If we double this, we get 6.4. So maybe it looks like it's about 9.6 would be our approximation. This one's more of an approximation here. All right, so that would be those three values. So that's the answer for part A. For part B, are these underestimates or overestimates of I? So to do this, we got to approximate what do we think I actually is. So first, to do that, maybe let's look at how many full boxes we have here. So going across there, that's 2, 3, 4, 5, 6, 7, 8 boxes. There's 1, 2, 3, 4, 5, 6, 7. So that's, we're up to 15, 16, 17, 18, 19, 20, 21 boxes. 22, 23, 24, 25, 26, 27, 28, 29, 30, 31 full box, or sorry, 32 full boxes there. So I'll write that down for I. We got 32 full boxes plus. Now we got to figure out how much extra we got there approximately. I don't know if we take that box and maybe that little overage there, that's another one. If we get maybe this one and this little extra, that's another one. And again, this is an approximation, but we're just trying to get close here. Maybe this little part and this little part's getting us close to another one. This one and this one might probably fill up another box. And the two remaining ones here, looks like both of them are both over half of a box there. So we got maybe another, I don't know, 1.2 boxes there. But that's the number of boxes. How big is each box here? Well, remember, we're going by halves. So each box is a half by a half. If we multiply 0.5 times 0.5, the area of one of these is 0.25. So if we take our number here, which is 32, 33, 34, 35, 36, about 37.2 boxes times 0.25, it should give us an approximation here of what this is. So let's see what we get here. So a decent approximation might be about 9.3 is I here. So we estimate I to be about 9.3. All right, so which ones are overestimates? Underestimates, that means 6 here is a underestimate for sure. This one's definitely an over estimate. Should probably add the word estimate here. And then our last one, this is the midpoint one definitely gave us the closest approximation here. But it looks like still this one is probably still a little bit slightly over here. So over estimate. Not by much though. All right, next they want us to use the graph to find T2. How does it compare with I? So if we're going to find the trapezoid approximation here of T2, the two trapezoids we'd be looking at right here. So we'd be using that. Those would be kind of the two bases. There's one trapezoid. The other trapezoid is also going to use that line at 2. Here's the other base. That's the height. There's the other trapezoid. So that should give us a very good approximation. It's going to be a little bit under the actual value of I, but should give us a pretty close estimate there. So our change in x, or our height, is still 2 here, but remember with a trapezoid we're dividing that by 2 because of the way you find the area of a trapezoid. And then in here actually it's our change in x over 2. And then here we'd be doing this length, there's one of those, f is 0. This line is the bottom of the first trapezoid and the top of the second trapezoid, so there's 2 of those, 2 f of 2's. And then their final line here just is using that second one, so f of 4. So now if we fill that in again, this is, we already had said that's 2. Our f of 0 is 0.5. Our f of 2 came out to be 2.5. And f of 4 is 3.5. So if we multiply that out, add them up, we get 5 plus 4 is 9. And so this estimate's going to come out to be 9. And that is, based on the I we got, this is a little bit of a underestimate, which it should be. All right, final thing they want us to do for any value of n, list the numbers ln, rn, mn, tn, and I in increasing order. So the smallest one we came up with was L2 here was our smallest value. Our next biggest value looks like it came out to be our T2 value, which is 9. Then I would say the actual value I, which is, we estimated about 9.3. And then our midpoint approximation, and finally the right endpoint gave us the biggest approximation. So that would be increasing order for part D.